How do you determine good versus great amplifier performance? That's what we're going to be talking about in today's video. Hey folks, I'm Gene Delasalo with Audioholics. I want to do some amplifier talk with you guys. I thought about this because people are always asking me, how do I really know if my amplifier I'm getting is really exceptionally good? And I want to do some pre-qualifiers before we get really deep into this topic. Number one, I'm not bashing any amplifier manufacturer out there. I'm just using my measurements that I've collected over the last 20 plus years to give you examples of how to determine good performance versus really excellent performance. You could buy whatever amplifier you feel you like best. I'm also not telling you about the audibility or declaring that one amplifier is going to sound better solely just on measurements. I'm just showing you a trend to show you what good versus great amplifier performance is. Audibility often is a lot harder to discern than to discern the differences on the test bench. Just want to make sure you guys understand that. With that said, I'm going to share my screen and we're going to do some measurement talk so you guys could better understand good versus great amplifier performance. So we start with frequency response. You really got to start with an amplifier that has linear flat frequency response for the entire bandwidth from 20 hertz to 20 kilohertz, preferably even higher than that. You want to go at least, an octave or so above that bandwidth to be flat. You don't want to have extremely wide bandwidth like the 500K because then you can amplify RF noise and have these all other problems, and you don't want that. So I wanted to give you this example here. This is a Class D amplifier. And I chose this one because historically, Class D amplifiers' biggest problem was their frequency response would drastically change with different load impedance. In other words, there were not load invariant amplifiers. And a lot of that had to do with the way that the feedback was being done in the amplifier. This is one exception. This model, I don't even think it's around anymore. I did this review maybe 6-7 years ago, but it was one of the first Class D amplifiers that I measured that had extremely linear response regardless of what impedance was being driven. So in this plot, I'm showing you a no load condition versus an 8 ohm load condition versus a 4 ohm load condition. And the frequency response is unchanging. That's awesome. That's what you want for frequency response behavior in an amplifier. Most Class AB amplifiers have this kind of response. Not all Class Ds do. And I want to give you an example of a Class D that I measured in the past that does not. This is the Axiom audio amplifier. It was a Class D amplifier. They came out with their first generation Class D. They've changed the model since then, so I don't know how their new ones perform. But look at that frequency response at very high frequencies. This is a no load condition that was giving me a 3.5 dB peak, which is not good. You don't want an amplifier to change its frequency response. And then when I measured it at 8 ohms, it was flat, but then at 4 ohms, it was tapered off at 20 kilohertz. So this was changing with frequency response. This is what you don't want in an amplifier. And this is, like I said, the amplifiers, the Class D amplifiers that were coming out over a decade ago, many of them had these problems. This is one of the most extreme. I never measured an amplifier with such a nonlinear frequency response as I did with this one. So that takes care of the frequency response aspect of amplifiers. You want a linear response. You don't want a changing frequency or changing shape based on the impedance that it's driving. So I want to show you guys, I know you're familiar with this power sweep versus distortion measurement, but people tend to just look at this for figuring out how much power their amplifier will deliver. They never really look at the finer details. And I think it's really important to look at this. So if you look at this is from a Class A CT 2300 amplifier. I think it's around $6,000 for a 2-channel amp, $7,000, something like that. So it's not a cheap amplifier, but this is an engineering marvel. If you look at, really look into why I'm saying that, look how flat that vertical line is for power versus distortion. And in poorer amplifiers, you won't see it be that flat. And look how low the distortion is before clipping, before the knee of the amplifier. So we're at basically at 0.003% distortion. Now, if you want to convert that to SINAD, I know you guys at AV Science love that stuff. You just divide that by 100 times log and times 20, and you got 90 dB sine add on that. That's really good. 90 dB of distortion all the way out to its power limit. Now, this amplifier is rated at 300 watts a channel, and look where the knee is. The knee is above 300 watts. It's at like 340 watts, and it's extremely linear and flat. This is a beautiful power versus distortion curve that you see here. Now, I want to show you in comparison one that's not so beautiful. And we have back to the Past Labs amplifier. Now, this is a $11,000 amplifier, much more expensive than the Class A. You see how the curve is no longer flat? It's really good at low power. I mean, Past Labs claim to fame with Nielsen passes, the first watt matters. And yeah, I could see that. In this case, when I measured this amplifier at 1 watt, the FFT on it was really clean. The distortion was clean. Everything looked great at 1 watt. But as you started driving this thing towards its rated power, I think the rated power in this is 350 watts. It goes from 0.005% THD all the way at 300 watts to 0.03. Again, this is probably not audible, but it's still not, state of the art. You're looking at 70 dB sine add. That's 20 dB worse than the Class A amplifier. So it's not as clean. For an amplifier that's twice the price and has 20 dB worse distortion at rated power is not something that I qualify as great performance. I qualify this amplifier as good performance, but not for such an exorbitant price. Now, granted, the Past Lab amplifier is beautiful. I mean, it looks awesome. It's probably one of the best looking amplifiers I've ever seen, but it did not produce the kind of bench test results I was hoping for an amplifier of this stature and price class. And I want to show you a couple more examples of ones that measured really well. So here's the monolith, monoprice amplifiers. These are pretty cheap. These are around, $1,500 to $2,500 or $3,000, depending on how many amplifier channels you buy it with. If you look at this power versus distortion, I think this amp is rated at 200 watts. Look how flat and even and linear the power sweep is all the way to its rated power. Now, I did that at 8 ohms and at 4 ohms. That is really good. The guys behind ATI designed this amplifier. They know what they're doing. They've been doing this for decades. Very few companies have more knowledge in amplifier design than ATI. And you could see that here. This is a stellar measurement for an inexpensive amplifier. This distortion profile is superior to what was on that $11,000 Past Labs amplifier. And in my opinion, that's inexcusable for when you're spending this kind of money to not get this kind of performance. So this is really great performance, very flat linear response all the way to the knee. Above 200 watts is where it's rated, and it's clean and it's even. I want to show you another example. We got the Anthem STR. Now this is a 2-channel amplifier, fully differential outputs. Again, this is another example of stellar performance. Now, this is an expensive amplifier as well. I think the price on it's, somewhere around $5 or $6 grand. Not cheap, but you are getting state-of-the-art performance here. Look how low the distortion is. Look how linear the power sweep is all the way to the knee at 440 watts, and it's not even rated to 440 watts. So you're getting more power than it's rated for. Again, it's just like the Class A examples, just like the monolith example. This is good performance. You're getting very linear power response here, and this is what I like to see. Let's see if we have another one here. So back to that Class D I was telling you about, the IQ audio. That one had great frequency response. As I told you, it did not change frequency response depending on the load it was driving. But the Achilles heel of this amplifier, because it was such a small amp, it was like a pint-sized amplifier, and was only rated to, I think, 200 watts. Look how nonlinear the power sweep is. So it's good over till about 100 watts, and then it just starts getting really high in distortion at its rated power. This is exactly what I was hearing when I hooked this amplifier up. To me, it sounded phenomenal. It sounded equally as good as my Emotiva XPR1 1 kilowatt monoblocks at low power. But when I started cranking the power, I started hearing compression, and I started hearing not necessarily bad distortion, just not clean. This amplifier was definitely limited by the power supply, and you could see that here in this power sweep. This is not giving you a linear horizontal sweep out to its rated power. And there's an indication right there where you separate the men from the boys in amplifier power. So the next thing I want to show you is an FFT. And this is something I look very closely at in both amplifiers and in preamplifiers. Now, this is the Denon PMA 110 integrated amplifier. I think it's about $3,500. Don't quote me on prices. I really suck at remembering that. So with an FFT, you don't want to see, what you want to do is you want to see the fundamental, which is at 1 kilohertz, and you don't want to see a lot of spikes after that. You are going to always see spikes, but you want those spikes to be, relatively low in amplitude. These are the harmonics that the amplifier produces. Now, at 1 watt, generally you won't see these spikes, and I could show you examples of that in other videos when I always show in my reviews 1 watt and full power. This is at full rated power for the Denon, and the first or the second order harmonic is at 2 kilohertz, and it's 91 dB below the fundamental. That's excellent. I like to always see at least 70 dB, 80 dB at full rated power. I think that's excellent. At 1 watt, I'd like to see that even lower. But minus 90 dB is the second order harmonic when this amplifier is hitting its limit. It's basically at its rated power. Now let's go back to that X350. So this is at 1 watt. As I was telling you before, Past Labs is all about that 1 watt, which is great. You see no residuals here. You see no harmonics. You do see a high DC offset at 20 hertz, as you can see the elevation there. I'm not too happy about that. I probably should have looked further into that when I did the measurement, and I just kind of ignored it. And that's something I always like to look for now. I mean, I did this amplifier review maybe 7-8 years ago, but it's important that you're not amplifying DC with power. I mean, that's how you fry tweeters and you fry speakers. But anyways, at 1 watt, this Past Lab amp is excellent. There's no harmonics that I measure here. As I said, that Past Lab amp sounded beautiful at low power, but look what happens at rated power. This is probably the worst distortion profile I've ever seen in an amplifier. This is at less than 70 dB. Like I was telling you, I'd really like to see 70 dB or greater for the harmonics. But look at how just jagged it is. It's just not good. Just not good in any way. I don't understand exactly why that is, other than the fact that Past Labs is not a big champion of doing a lot of feedback. And that would explain why this thing kind of falls apart at rated power. This is just not a pretty FFT curve. It's really inexcusable for an amplifier that's $11,000. And I know there's people out there that own Past Labs. I'm not trying to insult you. If you like the distortion profile that you're hearing when you're really hitting the rails on this amplifier, then more power to you, or in this case, less power to you because you're hearing more distortion. And when I did my testing on the Past Lab amplifier, I did have problems audibly in what I was hearing when this thing was hitting at high SPLs at bass frequencies. And I'll show you a little bit more about that when I show you the measurements as to why that's the case. So FFT, again, you don't want all of these nasty spikes, or you want them much lower in amplitude than what you're seeing here. You saw it with the Denon. The Denon had much superior FFT at rated power. So the next thing is SNR. And that's just basically how quiet the amplifier is. I always measure amplifiers SNR at 1 watt. That way you could take my SNR measurements and you can compare them from one amplifier review to the other. All my measurements on SNR are usually done with A weighting, unless otherwise specified. Now, the Past Lab amp at 88 dB at 1 watt, that's very quiet. It's not state-of-the-art, but it's very quiet. That's a good measurement. I like to see, at least 80 dB SNR. Preferably 90, really, but 88 is really close. But let's compare that to the Class A amplifier. It's a whopping 6 dB, almost 6 dB better. Well, maybe about 4 dB better on the other channel. But still, the Class A amplifier is quieter. And in reality, is that going to be an audible difference? It really depends on the sensitivity of your loudspeakers, how far away you're sitting from the speakers, and how good your hearing is. these are both good measurements. I'm not going to really fault past labs. I think 88 dB is sufficient. So here's the interesting thing I want to show you on amplifier power. Past Labs rates this amplifier at 350 watts at 8 ohms, 700 watts at 4 ohms, but they don't specify the number of channels driven. And when you look at my power sweeps here, you can see that at 8 ohms, I was hitting the rated power at 370 watts at 0.1% with both channels driven. But when I drove 4 ohms, I was only getting about 490 watts. That's way below the 700 watt rating. And this is exactly what I heard when I was cranking this amplifier in my old theater room, the Audioholics Showcase home with the Status AT speakers. Those were 4 ohm speakers. They had 3 10-inch subwoofers in them. They dipped down to 2 ohms in the 50 to 60 hertz range. They were a very difficult speaker to drive. This amplifier was running out of power. Like the whole front excuse me, the whole front panel of the amplifier was dimming as the bass notes were hitting. And it was really because they put too small of a power supply in such a high rated power amplifier. I looked at the voltage, transformer rating on the amplifier, and it looked like it was about 1200 or 1500 kVA. It wasn't a big enough transformer for such a large, supposedly powerful amplifier. So this amplifier had much more difficulty driving 4 ohm loads than it should have, especially at its price point. Then you go and compare it to the lesser rated power Class A amplifier. And you notice I did continuous full power bandwidth on this as opposed to just power sweeps. I was having issues running continuous full power bandwidth on the past lab, so I had to only do it at 1K. But in this one, I did not have a problem. This amplifier was just bulletproof. 300 watts a channel rated Class A amplifier was giving me, 340 watts full bandwidth at 0.1% with both channels driven. And then with 2 channels driven at 4 ohms, it was giving me a whopping 590 watts at 0.1%, 610 watts at 1%. It was meeting their continuous power rating. They specified both channels driven. This is what you need to look for when you're buying an amplifier. Make sure you know how they're rating the power. This Class A amplifier is extremely conservatively rated. And the beautiful thing about it, this is what separates the men from the boys. An amplifier should act like an ideal voltage source. So whatever the power rating is at 8 ohms, ideally it should double that power into 4 ohms. And that's exactly what this amplifier, this Class A amplifier did. Pretty close with what I found with the monoprice amplifier that did the same thing, the 2-channel. Very hard for you to get this kind of behavior with a receiver unless you're dealing with the old flagship receivers like the Yamaha RX-Z11s or the Denon 5805s. Those are a different class of receivers. They don't make those kind of receivers anymore. So if you want to get amplifier performance that doubles down with having load impedance, you need an amplifier like this. You need one that is continuously rated, both channels driven for 8 ohms and for 4 ohms. The Class A amplifier was clearly doing that where the past lab amp was not. So, just to recap, we talked about frequency response. You want linearity and frequency response. You don't want the frequency response changing when the load impedance changes. The advantage there is that amplifier will sound the same no matter what kind of speaker it drives. And that's really important. That's, when people talk about synergy, you could eliminate the whole synergy argument if you have an amplifier that doesn't change its frequency response when the loudspeaker impedance changes. That's one thing that's important. We talked about the power sweep test that I do to show that amplifier has really linear power all the way up to its rated power, up to the knee of the graph. You want that horizontal line to be very low distortion, as you saw in the monoprice amplifier. You saw it in the Class A. You saw it in the Denon amplifier. You did not see it as well in the Past Labs amplifier or in the IQ audio amplifier. Then the other thing is you want to look at the FFT spectrum like I do. Most magazines don't even look at FFT. It's really important to look at an FFT to make sure you don't have a bad DC offset in the amplifier, or you just don't have bad residual harmonics at both 1 watt driven and at full power driven. really it's the most important at 1 watt. You don't want to have bad harmonics at 1 watt because 1 watt is at a low listening level. You don't want to amplify distortion when you're trying to listen to those little finer details. And in that regard, all those amplifiers pretty much did really well at 1 watt, especially the Past Lab amplifier. That lives up to their claim that the first watt matters. Unfortunately, it's the higher power that they don't talk about is mattering. In my opinion, it matters at all power levels. There's no excuse not to have it matter at all power levels, especially in today's modern day of amplifier design. The other thing that's important is the signal to noise ratio. That's really hard to mess up with a 2-channel amplifier or a multi-channel amplifier. 80 dB at 1 watt or greater is really considered good. If you hear some amplifiers that have a lot of hissing, probably their SNR is not the greatest, or they have a lot of voltage gain, and you have high sensitive speakers and you're hearing that hiss. So you got to kind of look very closely at that when you're buying an amplifier to check on what their SNR is rated and, you know, what the sensitivity of your speakers are, just to make sure you don't buy an amplifier that just lets out a lot of hiss. And then, of course, the last but not least is the power. Being able to double down with having load impedance is important, especially if you're using, you know, low impedance speakers. So if you're using tower speakers like the ones you see behind me, most towers that have multi-driver arrays, like multiple woofers, mids, and tweeters, they're going to be 4-ohm speakers. Even if the manufacturer says it's an 8-ohm speaker, they're lying. Guaranteed that they're a 4-ohm speaker if they have multi-drivers like that. So anyways, I hope you guys found this video useful. You know, I try to really keep the measurements down to earth so that you understand what we're showing you here. And again, I preface with the fact that not everything that I measure is audible, but you know, for good housekeeping, you do want to have the cleanest performance possible. That way that amplifier will work good in any scenario. You know, I really think I like over designing things, and you could see that with what I showed you with the Class A amplifier, for example. That's just a superb amp. I really hated seeing that amplifier go. But now we've got Class D amplifiers that have incredibly good performance, and I'm going to be doing some measurements on the latest generations from Hypex. I've got the, I'm trying to remember, Pascal amplifiers in the RBH system. I'm going to be measuring those. And of course, Purify, NAD uses Purify, which are incredibly good, very linear amplifiers, very low distortion, very low noise. So guys, I hope you found this video useful. Please subscribe to the channel, hit the like button. Don't forget about our Patreon at patreon.com/audioholics. You get direct access to us if you want to ask questions or suggest video topics. And also you get to help us continue to produce this content that you guys enjoy to watch. So until next time, my friends, keep listening.